Hi everybody, I want to tell you a little bit about our ESD3 project. My name is Alex Erdman, and I work with Brendan Tawa on a project we'd like to call DragonFruit. And that's partly because the inspiration came from Professor Mondragon and his aspirations to have some sort of system that could watch over his elderly mother who lives in Mexico. And unfortunately there's really no easy way to do that because typical home security, home monitoring systems like we have up here, like ADT and Philips Lifeline, aren't available down there. So we were trying to come up with something that was cost-effective and easy to implement. So what we ended up doing is taking pretty standard off-the-shelf parts like smoke detectors, motion sensors, other things you find in your home, and interfacing them with Raspberry Pi via a couple different devices like Electric Imp. And we run some services on here like HTTP and Python, and we collect all this data, and then we make decisions on it in real time to determine if everything's okay with the person and their environment, or if they're in trouble and need help, and in that case we alert their family member. We're working with a couple other technologies like the TI MSP430 watch, and if you wear this watch it's got an accelerometer in it and we can actually detect falls and other sorts of motion. So anyway, we'd like to demo the product for you now, and we think it's pretty cool.
Here we have the DragonFruit webpage. It displays all our data that we grabbed from the SQLite database, and from there we use a Python script that generates an HTML table in real time based on the data entries that are in the SQLite database. Below you can see that these are our COSM graphs, so they display data in real time that comes from the COSM cloud that reports the data from our sensors.
Here we'll take a look at some of the environment monitoring features in DragonFruit. This is similar to your typical home security system in that it includes motion detection and smoke, fire, and carbon monoxide. So these devices, which are off-the-shelf sensors and alarms, are connected to our system via the Electric Imp, which is this SD card sized device, and it features an ARM Cortex M3 microcontroller and also a Wi-Fi radio. So we connect these devices to the Imp, and then the Imp reports to its own cloud-based web server, which is the same place that the device is configured from. So we can see that it reports the data in real time to their service, and then we output from them to our own HTTP server and also to a third party called COSM. So when our server receives the data, we parse it in real time and then write it to an SQLite database for future review and display on our web page. And we'd like to demo the functionality of the sensors and the overall integration with the system between the sensors and the web page itself. So we reset the event counters on our web page to 0, and we're going to go ahead and connect the motion detector to its Electric Imp, and Tawa is going to activate it, and then we'll refresh the page and we can see that an event is logged. And there we go, it gives us the time and date of the last motion event, which was today at 3:46 p.m. Then next we'll take a look at the smoke detector, and it works similarly. However, since we're in a commercial building right now, we won't actually use the smoke alarm. Instead, we'll just create a switch to mimic its signal. So Tawa's going to go ahead and close the switch. And again, currently we have no smoke alarm events, and we'll refresh the page. And you can see we got an event and an alert email telling us that there's trouble. In this video I'll demonstrate the functionality of fall detection using our MSP430 based watch from TI. So the watch transmits accelerometer data in real time via RF to our Raspberry Pi, and then we have a script that catches that data and computes a running average, a moving average actually, with each new sample. So then what we do is compare the moving average of the last 5 samples received to the real value of the current sample, and if there's a strong difference between the two, that's how we know there's been a fall. So the Python script is running, we started the wireless access point, and now it's just waiting for something to happen. So I'll go ahead and start the transmitter on the watch. This is actually the guts of the watch, the inside. It's a little bit easier to manage. So we got that started, and now we'll drop the watch, and you can see we have a fall event, and it's beginning to send an email alert. And there you go, we just got our email alert that there's been a fall.